We somehow missed all the lessons on decimal numbers earlier while presenting the lessons on numbers and operations. And here they are. Decimal numbers is in itself the 11th lesson in the series. So, let us begin this introductory lesson on decimal numbers. None of us is as smart as all of us. Kenneth Hartley Blanchard asserted this open secret. I am reminded of this whenever thoughts cross about the history of numbers. The decimal number system, the Indo-Arabic numbers, is an example of collaboration between two great civilizations, Indian and Arabic. While zero was well documented and elaborated by the Indians for use in a positional number system, the Arabs put the decimal number system together as a positional number system. Welcome to the decimal number system. There is much more to decimal number system than what is common knowledge. For instance, what is so fundamentally 10 about the decimal numbers, beyond the decimal digits 0 to 9? It is the fact that 100 is 1010 and 1000 is 110. At the most basic level, decimal numbers represent how many packets of 10 in a number. Thinking about how to read 101, to be right, it is 10, 10 and 1, that is, how many 10 and whatever is left to be 10 less than 10. As another instance, why do we write 10, the first decimal number after the decimal digits 0 to 9, as 1 and a 0? Writing 10 as 1 and 0 was one of the biggest human achievements. A triumph in writing positional number system. Stating 10 as 1 and 0 is to say that it is one packet of 10 and nothing more. Obviously, after 10, it is 110 and a 1, that is one more than the 0 in 10, and 11 is 1 and 1. Back to how decimal numbers are counts of 10 and whatever is less than 10. Here is 20,003 as 2,000 packets of 10s and 3 packets of 1s. Of course, true to being a decimal number system, the different packets of 10 have a name for themselves. For example, 1010 is called 100 and 10 hundreds is called 1,000. Interestingly, beyond the 1,000 we get miser on naming to avoid too many names of numbers, and we name packets of 100s or 1,000s. For example, 1,000 million is 1 billion. Decimals draw their immense practical power from simplifying representation of fractions. And how that may be possible? By simplifying the possible unit fractions? Decimals allow only 1 by 10, 1 by 100, and so on, as the unit fractions. The picture visualizes the unit fractions possible in decimal numbers, up to 3 decimal places. For example, in 11.587, there are 5 parts of 10 parts of 1, 8 parts of 100 parts of 1, 7 parts of 1,000 parts of 1. Another beauty of decimal fractions is how it is easy to see that the sum of all the different unit fractions in a given number is always less than 1. For example, if 1 by 1,000 is the unit fraction in a decimal, there cannot be more than 9999 of 1 by 1,000. The fractional decimal part is made of different sizes of parts of 1. In just the opposite way, the non-fractional, whole part of decimal numbers is made of multiples 1 or 10 or 10s and 1s. What is half in decimal form? Half is one of 2 equal parts of 1. In decimal, it must be expressed as a number of parts of 1 by 10 each, that is equal to 1 of 2 parts of 1. We will start with visualizing half as a part of 1, and then see how much of that one part is in terms of 10 equal parts of 1. Let's see an enlarged view of unit block, or 1, and split it into 2 vertical equal parts or slices. The shaded part is 1 part of 2 parts. Now again split the same unit into 10 vertical equal parts. We can see that now the fractional half is 5 parts of 10 parts. Thus half is 5 by 10 or 0.5. Get to the 3-part reals on decimals and discover the joy of visualizing numbers and operations. Thank you. With us, you will master all the mathematics you need. Be good to you, not just others.